Hi everyone, so we are now moving into graphing square root functions. Alright, so pause the video and try these factoring problems. We haven't done these in a while, so. Alright, so the first one, if you notice, the leading power is 6 and the middle is a 3, so that means it's an MC chart, so x cubed, and then we need to know what multiplies to negative 64 and combines to negative 63. And that's negative 64 plus 1. Gives us that negative 63. Now notice these are perfect cubes, so then we're going to use our perfect cube rule. So 64 is 4 to the third. So that's x minus 4. And then remember, square the first, switch the sign, multiply them, square the second. And then for the second one, x cubed plus 1, that's x plus 1. Square the first, switch the sign, so 1 minus 1 times x is x, square the second. For number 2, there are 4 terms. So whenever there's 4 terms and it says 3, 2, 1, nothing with the x's, automatically I'm going to try factor by grouping. So I'm going to factor the first 2, and I get 9x squared. Factor the second 2, minus 4. So that gives me 9x squared, and then we get 3x plus 7 minus 4, 3x plus 7. So now I'm going to factor out the 3x minus plus 7, and I'm left with 9x squared minus 4. And then finally, 9x squared plus 4 is 3x plus 2, 3x minus 2. Now, I've been seeing a lot of kids do that because they see 2 of them. But remember, it's really a GCF, but the GCF is a binomial. So we're dividing by 3x plus 7, dividing by 3x plus 7. So it's not a squared, right? Think of that as one big GCF. Okay, sorry this is so little. So we are going to sketch the graph of the following. So this is parabolas. We haven't done these in a long time. So remember, our parent function of a parabola is this, right? So these are all based on the parent function. What would we do to graph x squared minus 8? So pause and see how many of these you could figure out. So x squared minus 8, that outside number, remember, just shifts down 8. So it would be here. Right? So our vertex is 0, negative 8. Right? Just go down 8. Now when we have something on the inside, that shifts it to the right. Right? So we change the sign of the inside. Because if we plug in 8, what do we get? 0. So we switch the sign of the inside to make that 0, and then we're left with, 8, and then we're left with 0. All right, so now what if we have an inside and an outside? Again, what will make the inside 0? Negative 8. If you plug in negative 8, what are you left with? 5. So that's your vertex. So negative 8, 5 is the vertex, and then we just go over and up. Same idea. What will make the inside 0? 8. When you plug in 8, you get 0 here, and you're left with negative 5. This one's slightly different, though. How is this one different? 8, negative 5. There's a negative in front. What does that do to the graph? Flips it upside down. Good. All right, this one, negative 4, right? That'll give you 0, negative 5. Oops, I drew my graph wrong. I need quadrant 3. Like that. So negative 4, negative 5, say there. And then there's a 2 in front. What does that do to the graph? It makes it skinny, right? Yeah. And then last one. So the inside is a 7. So it's 7, 2. And then again, it's to the third, so it's going to be super skinny. Right. So I didn't really, these were sketches, right? Who remembers the shifting rule? What was that shifting rule we used when we plot these? So over and up. 1, 1, 2, 4, 3, 9, 4, 16. Why is that our shifting rule? Because this is based on x squared, right? 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. So when I plot, say, number 2, I start here, and then I just count over 1, up 1, over 1, up 1. Back to my vertex, over 2, up 4, over 2, up 4, 1, 2, 3, 4, right? Over 3, up 9. So, and you're always counting from your vertex. So the reason we reviewed this, the square root is very, very similar. What is the relationship between x squared and the square root? A lot of kids keep telling me, oh, they're opposites. Okay, what's the mathematical term for opposites? They are inverses. They are inverses. So what do you think that means in terms of the graph? So there is a relationship between the graph. So they are. So think about how the x's and the y's are related, right? So if I have x squared, right, think about a table, right? So it's 1, 0, 0, 1, 1, 2, 4, 3, 9, right? And that's just plugging in, and that's our shifting rule, right? What if we had the square root of x, though? What do you think? Right, if I plug in 0, I get 0. If I plug in 1, I get 1. What's the square root of 2? I don't know. So what number would be a good number to plug in then? Right? What's a perfect, we want perfect squares. 4, 2. What's another good perfect square? 9. The square root of 9 is 3. So notice the tables are reversed. Right? So with that shifting rule, what we can do is instead of doing 0, 1, 1, 2, 4, 3, 9, it basically just flips the x's and the y's. Because they are inverses, our x and y shifting rule switches. Just don't forget, these are actual tables, not really shifting rules, so don't forget your 0, 0. Okay, so using that fact, I want you to graph the square root of x. So 0, 1, what's the next number we plug in? 4, 9, 16, right? Square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, square root of 9 is 3, square root of 16 is 4. And remember, this is the parent function, right? Or as I like to say, the mother function, because it's funny sounding. All right, so I'm plotting the points 0, 0, 1, 1, 4, 2, 9, 3, and 16, which doesn't fit, so I'm done. All right. Okay, so this is very similar to a parabola. Do you see the parabola? All right, if you don't, turn your head right. Turn your head to the right. It's actually a sideways parabola, right? Remember, a parabola looks like this. Right? So basically what we do is we erase the right side, and then it falls over. Right? We erase the right side of the parabola. Right, so this side is gone, and then it falls over to the side. So it's a sideways parabola. We're going to skip this. We're going to get to this another day. I forgot to erase it. Okay, so write these down. Use your graph paper. I want you to see if you can figure out what these look like. Use a chart if you want. Think about our vertex rule. Look back at what we did with the square root, with the x squareds, the parabolas. What did we do to figure out the vertex? Okay, so if I have the square root of x minus 3, think back. What if I had x minus 3 squared? What's the vertex of that? Change the sign of the inside, outside stays the same, right? It's the exact same thing with a square root. So 3, 0, right? If I plug in 3, I get 0. And then what else can I plug in? If I plug in 4, I get 1. So that's actually over 1, up 1. Now, I don't really want to plug in 5, right? If I plug in 5, I get the square root of 2. I don't know what that is. So what's another good number to plug in? 7. If you plug in 7, what do you get? That's the square root of 4, which is 2, so 7, 2. So 7, 2. And notice that is actually over 4. 1, 2, 3, 4, up 1, 2. The square root of 4 is 2. So this is our shifting rule. So we find our I like to call it the starting point. It's not really a vertex like it is with a parabola. So I call it my starting point, and then I'm just going to use the reverse shifting rule of an x squared. All right, so what is the starting point for this square root? It's got an outside number. What will make the inside 0, 0, and then 3. So I start with 0, 3, and then I'm going to go over 1, up 1, back to my starting point, over 4, up 2, back to my starting point, over 9, up 3. Right? Because it's based on a square root, over, up, 1, 1, 4, 2, 9, 3. Now, when we say over, it's usually right. We're going to get into that a little later, the rules there. But we're pretty much going to the right because think about, can I plug in a number to the left? Can I plug in, say, -1? No, that's an imaginary number. And we're not dealing with imaginary numbers right now. Right? We're only dealing with real numbers, positive, under the square root. All right, again, change the sign of the inside. That cancels the square root, and we're left with 2. So change the sign of the inside. Outside stays the same. So there's my starting point. And then I'm going to use my shifting rule. Over 1, up 1. Over 4, up 2. Back to the starting point. Over 9, up 3. Can I fit 16? And it'll be at 11, right? -5 plus 16 is 11, up 4. 1, 2, 3, 4. So it's like here. These are kind of weird too, because they kind of look almost like a line. There's not a they kind of look linear, don't they? It's okay. That's why we plot the points. Plot as many points as you can fit so that we can see that it actually is a curve. All right. This one, what do you think? Same thing, -4, 7. So -4, 7. 1, 2, 3, 4, 7. Now, over 1, instead of going up, what do? Down. So over 1, down 1. We're still going to the right, though, right? Because if I plug in -3, that gives me square root of 1. There's that. So -1 plus 7 is 6. Over 4, down 2. Over 9, down 3. I feel like the upside down ones look even weirder than the normal ones. Okay. Again, these rules are exactly the same as the parabola. So -2, +2, -4. 1, 2, 3, 4. All right, so now, what do we do when there was a number in front? Over, up, 1, 1, 4, 2, 9, 3. Who remembers what we did? That multiplies the up. The y value is increasing. So we're going to multiply each of these by 3. 1 times 3 is 3. 6, 9. So instead of going over 1, up 1, we're going to go over 1, up 3. Over 4, 1, 2, 3, 4, up 6. And over 9, up 9. It's an equal, not a negative. So 9, it's like here. All right, so what do you notice about this? If you remember, 3x squared is really skinny. Is this really skinny? No. Or narrow. I really shouldn't use skinny. This is a narrow one. This one is not. And it's because it's the inverse, right? Because you're doing the opposite of multiplying by 3 is actually dividing by 3 when you're multiplying. All right, last one. So we've got 6, right? Change to the sign. Now this one, what will make the inside 0? It's 6, 0. This one's a little harder though. 1, 2, 3, 4, 5, 6. Because why can I not go right one up one? What's to the right of 6? 7. So h of 7, that's the square root of 6 minus 7. That's -1. That's not allowed. So instead of going to the right, we're going to go to the left. So anytime x is negative, we end up going left. So over 1, left 1, up 1, left 4, up 2, left 9, 6, 7, 8, 9, up 3, and then 16, 4. So because the x is negative, it ends up moving because that gives you that double negative. If I plug in a negative, x minus 6 minus -3, say. Right, when I plugged in that -3, that ends up working out nicely. Square root of 9, which is 3. Okay, so the rule is, I'm going to make it right, just so we don't get confused. So our rule is right, up, 1, 1. Oh my goodness, my brain sometimes. 4, 2, 9, 3, 16, 4. And then a negative in front. In front of the square root, flips it upside down. Okay, I'm running out of space. And then over here, a negative in front of x. Right, the square root of some 11 minus x makes the graph go left. All right, so those are your rules. Okay, so using that fact, see if you can figure out a sketch. You don't have to go crazy with these. All right, so we've got, pause the video and do these if you haven't already. So I got change the sign of the inside, outside stays the same, 5, -1, and then it's just going to go to the right. This one, -7, 4, right? Change the sign of the inside, outside is +4, so -7, 4. And then what's this one going to look like? It's negative in front, so this is going down. This one, we have a 2 to make the inside 0, and there's no outside. That outside is going to make it wider. So we've got 2, 0. Now, this is going left, and what? This negative x makes it left. This makes it down. And the 2 makes it wide. So this one's going to look like that. And then lastly, 0, 6, because that's a 0. Right, that will make it 0. And then this is just going right. It's going to be a little wider. A way to think about this is the square root of 5 times the square root of x. So kind of like the number, when there's a number in front. Square root of 5 is like 2.2, right? So it'd be like 2.2 root x. So it's going up a little faster than a typical square root. All right, practice. I will see you later.